Here we're going to solve this system of linear equations using Cramer's rule. So the first thing to check for is to make sure that each of these equations is in standard form. So I have x and a y equals a number, x and y equals number. So these are in standard form. So I can just go ahead and now assign my variables a, b, c, d, e, f that I'm going to ultimately be using in these formulas for the x value and the y value. So let me go ahead and write an A, B, C, D, E, F. And these are going to be the values that I use inside these determinants. So for my x value, I have the ratio of a determinant here over another determinant. Same with my y value. And you'll notice the x and the y's have the same denominator determinant. So for my x, in the numerator, BC, EF. So BC, EF will be this pattern. So 2, -3, and then -6, 9. In the denominator, it's going to be the coefficient matrix. So DEAB, so DEAB, so -3, -6, with 1 and 2 with my A and my B. And you'll notice that the x and the y have the same, so I'm just going to go ahead and write that in there now for my y. Okay, so for the numerator for the y, it's DFAC, so DFAC, so it'll be -3, 9, and 1 and -3. Now it's just a matter of simplifying all these determinants and fractions. So 2 times 9 is 18, minus -6 times -3 is positive 18, so 18 minus 18 is 0 for that numerator. My denominator here is -3 and 2 makes -6, minus 1 times -6 is a -6. So we'll be adding, and we actually get 0 for that. So this is 0 over 0. So we know that the denominator here will be 0. So we need to check and make sure that both numerators here, we need to check their values. So let's go ahead and do this numerator. -3 times -3 is 9, minus 1 times 9 is 9, is 0. So you will notice that each of these, x and y, comes out to be 0 over 0. So since the determinant of the coefficient matrix is 0, we needed to look to see if either of the numerators or denominators were 0, and in fact both were 0. So the solution is going to be dependent, which means the lines are coincident, they're the same line, and the solution is going to have infinitely many solutions. So when I write my answer up here, I'm going to write infinite solutions. And again, this is because the lines are the same exact line. They are coincident.